In this video, we're going to talk about an application of quadratic functions, and this application will have to do with a baseball that is being thrown upward. So let's read the example. A baseball is thrown directly upward with an initial velocity of 96 feet per second, and just to give you a feel of about how fast that is, that's about 65 miles per hour, from an initial height of 7 feet. The height of the ball in feet after t seconds is given by the formula h of t equals negative 16t squared plus 96t plus 7. Now that formula really comes from physics. The 16 has to do with the gravitational pull of the Earth. The 96 was the initial velocity, the initial speed of the ball, and the 7 was the initial height of the ball. When the person released the ball from their hand, it was at a height of 7 feet. Okay, and the question is, after how many seconds will the ball reach its maximum height? And also, what is that maximum height? Now notice that h of t is a quadratic function, so its graph will be a parabola. And also, since the coefficient of t is negative, it's negative 16, it's going to open downward. In fact, if we were to try to graph this, it would look something like this. Okay, the 7 here, that's going to be the initial height of the ball, right? H of 0 is 7. And the question is, what is the maximum height of the ball? Okay, so we could ask, first of all, what is the vertex of the ball? By the way, this axis will be the time axis, and this will be the height, right? H of t. And the question is, at what time, after how many seconds, does the ball reach its maximum height, and what is that maximum height? Okay, what are the coordinates of that vertex? Okay, now remember our formula for the axis of symmetry is x equals negative b over 2a, but actually since our variable is t this time, we'll write it as t equals negative b over 2a. Now notice that a is negative 16, b is 96, and c is 7. Okay, so if we plug these things in, we would get negative 96 over 2 times a, but a is negative 16. So that'd be negative 96 over negative 32, and that turns out to be 3. Okay, so what does that mean? Well, that would be 3 seconds. Okay, so t equals 3. That is this line right here is t equals 3, that vertical line. Okay, now the next question, so actually after 3 seconds, that's when the ball reaches its maximum height. And then the second question is, what is the maximum height? Well, what we need to do is find what is h of 3. Okay, we have this formula for h of t, the height of the ball after t seconds. So what's the height of the ball after 3 seconds? If we plug it in, we get negative 16 times 3 squared plus 96 times 3 plus 7. Okay, so that's negative 16 times 9 plus 96 times 3, that would be 288, okay, plus 7. And negative 16 plus 9 is negative 144, okay, plus 288 plus 7. And negative 144 plus 288 is positive 144, and add 7, that would be 151. Okay, so h of 3 is 151. In particular, the coordinates of this point are 3, comma 151. Okay, so this 151 is actually 151 feet. Okay, so if a ball is thrown upward, so directly upward, by the way, this does not really show the path of the ball. This almost looks like you're throwing the ball kind of toward the side. The ball is going straight up in the air. Okay, but at time 0, the ball is at height of 7 feet. Okay, and then at time t equals 1, t equals 2, it's still going up. And then finally, after 3 seconds, it reaches its maximum height. And that maximum height is 151. If you were to go over here, to this point over here, it would be at a height of 151. Okay, so we've answered both of these questions. And what is after how many seconds will the ball reach its maximum height, and what is the maximum height? And then the way we did that was we used the formula for the axis of symmetry, and once we found the axis of symmetry, we were able to find the vertex.